Hi again, this is the second lesson for section 2.9, and now we're going to actually solve some linear inequalities. The solving process is similar to solving equations. As you can see, we have an addition property of inequality and we have a multiplication property. Remember, the addition property also includes subtraction and the multiplication includes division. Now there's one special thing that happens when we're dividing or multiplying on solving inequalities. If we happen to multiply or divide by a negative number, we actually have to change the direction of the inequality. So let's say that we had negative 2x is less than 4. Let's make something simple here. Come back. I'm going to divide by negative 2. And when you divide by a negative, it changes signs. And so I have to rewrite that as x is greater than negative 2. I have to reverse the direction of the inequality. And so every time you do that, you will have to remember, oh yeah, I have to switch this direction. And that's the hardest thing, is that just remembering that, to do that. Anyway, let's go on with this. Okay, so we're going to solve, graph, and write interval notation. This is very common on how we do problems with inequalities. So to solve, that's negative 5 times x, so we will divide by negative 5. And rewrite that. Now remember, I have to switch directions because I multiplied by a negative, or divided. I divided by a negative. So then, when I get on this next step, I make that greater than negative 4. And then we can, oh my dog is barking. I don't know if you can hear that or not. And so to graph that, we're going to say x is greater than negative 4, and then we're going to the right because it's greater than. In interval notation, this is simply going to be negative 4 to infinity. All right, next we're going to, oh, I don't know if you can hear that, but he's barking a lot. We're going to subtract 4 on both sides of the equation, and so x is less than or equal to negative 3. Now we don't have to change the direction of the inequality if we're subtracting, only if we're multiplying or dividing. Now it's less than or equal to, so that means we have to put a bracket on the line, and we're going to negative infinity. And you always have to put your negative 3 on here because negative 3 is the number we're starting at, right? So it's got to be on your graph. Don't forget that part. To write the interval notation, it's negative infinity to negative 3. We put a bracket at the negative 3, parenthesis on negative infinity. So now we have the inequality, the graph, and interval notation for each one of these. So this is just a general steps like this. We did this for solving equations. We have the same thing for solving linear inequalities. We would clear fractions, remove grouping symbols, simplify by combining like terms, and so on. Now, you only have to do that in some inequalities, not all of them. So just use the steps that you need depending on the one you're given in the first place. All right, so notice this has a little bit more stuff going on than the last one. The same thing as solving equations. I want my variables on one side and I want my constant terms on the other. So I'm going to add the 8x, and then I bring down the 3. That's going to be plus a 1x, or just x, is greater than or equal to 10. Then we subtract 3 because we have to isolate the x, and x is greater than or equal to 7. And then once again, we're going to put this on the graph. Greater than or equal to means I have a bracket opening to the right because it's greater than. Don't forget to identify where you're starting at the 7. And by the way, 7 is included in this solution set. So if I ask you to identify some numbers in this solution set, then you could say, I'm having a hard time drawing my line here. You could say anything from 7 on. Well, I'm just going to start over. I'm trying to make it where you can see it, but it just gets real messy sometimes. I'm just going to leave it. I'm going to stop. Okay. So we're going to write interval notation. That's 7 to infinity. And back to that, what if I was naming things that were in this solution set? I could say 7, 8, 9, 10. I could say 7.5. I could say 8 3/4. Anything that's equal to 7 or higher is going to be in the solution set. All right, so I'm going to stop the recording again and start up with some more after this.